Hello children, once again welcome to our physics class. Hope you all are fine over there. In the previous session we had discussed the formation of p-type semiconductor and n-type semiconductor. Today we will discuss what happens when a p-type and n-type semiconductors are joined together. Okay, so let's get started with today's session. So first we will discuss about p-n junction formation. A p-n junction is the basic building block of many semiconductor devices like diodes and transistor. We will discuss more about diodes in our coming sessions. So what is a p-n junction? A p-n junction is formed when a p-type and an n-type semiconductor is joined back to back. So which is shown here. Here a p-type material is joined with an n-type semiconductor, and at the junction you can see a layer. This is p-n junction. It is the basic building block of many semiconductor devices. Okay, so certain process takes place in the formation of p-n junction. So let's discuss about the important process that occur in the formation of a p-n junction. The first process that occurs in the formation of p-n junction is diffusion. So what do you mean by diffusion? Diffusion is the movement of charges from higher concentration region to lower concentration region. So when you look at the formation of a p-n junction, you can see one side is p-type semiconductor and another side is n-type semiconductor. And on the p side, holes are the majority carriers, and on the n side, holes are the minority carriers. That means on the p side, the hole concentration is more, on the n side, hole concentration is less. So holes have a tendency to move from higher concentration to lower concentration region, that is from p side to n side. So this blue arrow represents the movement of holes from p side to n side. This is the diffusion of holes. This is diffusion, hole diffusion, because here holes move from higher concentration region to lower concentration region, and such type of movement is known as diffusion. And when you look at the movement of electrons, you can understand it is also a type of diffusion. Why? Because on the n-type or on the n region, electron concentration is more. On the p region, electron concentration is less. So electrons have a tendency to move from n-type or n region to p region. And this movement of electrons is known as electron diffusion. So this green arrow represents electron diffusion. So let whatever it be, if it is a Hall diffusion or electron diffusion, a diffusion current is formed because diffusion represents the movement of charged particles, and whenever the charges move, current is formed. Okay, so diffusion process leads to a current which is known as diffusion current. Okay. So the diffusion current, the motion of charge carriers due to the difference in concentration in the two regions of the p-n junction across the junction gives rise to diffusion current. Then what is another type of movement that is observed in the formation of p-n junction? Here a depletion region is formed when a p-n junction is formed. Okay, what is depletion region? See, on the p region, holes are the majority carriers, but electrons are the minority carriers. So this minority carriers will be accumulated near the junction like this. So this is the junction, and near the junction, minority carriers of the respective regions will be accumulated. So in the case of p-type semiconductor, electrons are the minority carriers. So these electrons accumulates near the junction. And in the case of n-type semiconductor, holes are the minority carriers, and these holes get accumulated near the junction. And near the junction, the accumulation of this minority charge carriers near the junction gives rise to a layer, and this layer is known as depletion region or depletion layer. And why do we call it as a depletion layer? Because within this depletion layer, these charges are immobile at first. Immobile means they can't move. If there is no movement of charges, there won't be any current. So this region is depleted of current conduction initially. Hence this region is known as depletion region. So what do you mean by depletion region? Depletion region is the region formed near the junction which consists of immobile minority carriers of the respective region. Okay, it is devoid of any current conduction initially. The space charged region on both sides of the PN junction has immobile ions and is devoid of any charge carriers. That is depletion region. So this results in the formation of depletion region near the junction. Now, depletion layer is formed. So when a p-type n-type semiconductor is joined together, a depletion layer is formed. When the depletion layer is formed, what happens? After the formation of depletion layer, an electric field is set up within the depletion layer, because you can see one end of the depletion layer is negative and another side of the depletion layer is positive, because on one side electrons are concentrated and on the other side holes are accumulated. So there will be a difference in potential between both ends of the depletion layer, and this difference in potential set up an electric field within the depletion layer. Okay, so the depletion region formation results in setting up an electric field at the junction, and this field set up along the junction acts like a fictitious battery. Fictitious means a false battery connected across the junction. We haven't connected any battery across the junction. Due to the formation of the depletion layer, a false battery or a battery-like experience occurs across the junction. And under the influence of this electric field, false field, electrons and holes begins to move within the depletion layer. So you can see here, this side is positive and this positive charges will be attracted to the negative side due to the negative potential here. And this side is negative and this negative charges will be attracted towards the positive side of the field. Okay, so due to this electric field, minority carriers within the depletion region begins to move. And this movement of minority carriers is known as drifting. Okay, so two types of movement is there. One is diffusion, another is drifting. Diffusion is the movement of majority charge carriers of the respective region, and drifting is the movement of minority charge carriers of the respective regions under the influence of electric field set up within the depletion region. Okay, so this electric field set up within the depletion region gives rise to a drifting. And due to this drifting also, a small current is produced within the depletion layer, and this current is known as drift current. Okay, drift current. Drift current is due to the movement of minority carriers within the depletion layer under the influence of electric field. And what happens when the depletion layer is set up? See, initially when a PN junction is formed, diffusion occurs, so the diffusion current will dominate, isn't it? Then when the depletion layer is set up, an electric field is established within the depletion layer, due to which drifting occurs and drift current starts to develop. So as diffusion process continues, drifting also goes on and the drifting will increase, and when the drifting increases, what happens? The drift current also increases, and as diffusion increases, more and more minority carriers are accumulated within the depletion layer, due to which width of the depletion layer increases. When width of the depletion layer increases, the electric field set up within the depletion layer also increases, and this potential difference between the ends of the depletion layer also increases and becomes strong enough that it doesn't allow further diffusion of majority carriers. This condition is known as equilibrium condition, and at the equilibrium condition, this diffusion current is equal and opposite to the drift current. Hence, net current through the junction in this equilibrium condition will be 0. So, this potential at which the further movement of majority carriers or the further diffusion of majority carriers are stopped is known as barrier potential. Okay, so what is barrier potential? Barrier potential is the value of potential difference set up within the depletion layer at which further diffusion of majority carriers are blocked. Actually, this potential acts as a barrier to the diffusion of majority carriers. Hence, this potential is known as barrier potential and it occurs at the equilibrium condition. At the equilibrium condition, net current will be 0. Why? Because diffusion current is opposite to that of drift current. If you consider the movement of or diffusion of holes, what is the direction of diffusion of holes from P type to N type? Isn't it? So the diffusion of holes is from P to N. But what about the drifting of holes? Drifting of holes will be from N to P. See, so the diffusion current will be opposite to the drift current. So at the equilibrium condition, this diffusion current will be opposite as well as equal to the drift current. So the net current through the PN junction will be 0 at the equilibrium condition, and the potential developed at this equilibrium condition is known as the barrier potential, and it is denoted by V0 or sometimes it is denoted by VB. Okay. So barrier creation, that is the next process. The electric field at the junction sets a barrier which opposes further diffusion of majority charge carriers through the junction. Thus, the barrier gets created at the junction prevents further diffusion. Width of the barrier. Width of the barrier is the physical distance from one side of the barrier to the other. That is width of the barrier. So if you consider this as the depletion region, this distance is the width of the barrier. Now, height of the barrier. It is the difference in potential from one side of the barrier to the other side. You know, one side of the depletion layer is at a higher potential, that means at a positive potential, and another side is at a negative potential. So the difference in height of the potential, okay, the difference in potential from one side to other side of the barrier is known as height of the barrier. Now drift current, you know drift current, due to the electric field developed at the junction, electrons from the P region move towards the N region. Similarly, Hall from the N region move to the P region. This results in drift current. The motion of charge carriers across the junction due to the electric field is called drift. So drifting occurs due to the electric field established within the depletion layer. This results in drift current. Now, what is the comparison of drift and diffusion current? Drift current is in a direction opposite to that of diffusion current. We had already discussed that. At a particular stage, drift current becomes equal to the diffusion current. So, when it becomes equal and opposite, the total current will be 0. So, this stage is said to be the equilibrium state when no current flows across the PN junction. Potential barrier becomes maximum at this stage and it is equal to VB, or in some books you can also see it as V0. Thus a PN junction is formed, and thus in a PN junction under equilibrium there is no net current. And this is the diagram of PN junction. We had already discussed this diagram. Now this is the barrier potential. See, so this is the height of the potential and it is denoted by V0, and this side of the barrier is at a higher potential or a positive potential, and this side is at a negative potential which is at a lower potential, and the difference in between these two potential is the height of the potential barrier. Okay. And this potential barrier prevents the further movement of or further diffusion of majority carriers. So that's all about the formation of PN junction. Next we will discuss about the PN junction diode.